you recollect from our last lecture, we actually first looked into what is functional requirements of, we looked into what are the functions of buildings, and then we started with types of load, and we nearly concluded that. We will just recapitulate a little bit of it right now, and then in today's discussion we will be talking about what are the functional requirements of buildings, and lastly we will try to find out what is the role of materials in the whole aspects of building and structure design. So, that is what would be our discussion. So, let us go back a little bit and look into what did you do in the last class. Okay. So, first we did was, yes, this is what we did, load type. We looked into special loads. I mentioned that temperature effects, shrinkage, moisture, hydrostatic and soil pressure, fatigue and fatigue load, and also load during construction, impact and collision, these are special loads. Then load combinations is one thing which one has to decide. Now, just only one point I would like to mention about the fatigue load again, which I mentioned in the last class. It is the repetitive load, load reversal. So, bridges, structures like bridges, they encounter fatigue load. So, number of cycles it can withstand, the load which that particular load which you can recycle for infinite number of times, that is what is called as fatigue load. Right. And now, combinations of load, the important point regarding combination of load is, all loads do not act together at their worst condition. For example, when earthquake load is at its peak maximum, same time the worst wind will never come. So, therefore, probability of all load at their worst is very, very low. So, therefore, you combine only certain loads together. For example, dead load, imposed load and possibly wind load, dead load, imposed load and possibly earthquake load. But you will rarely or never possibly will combine dead load, imposed load and earthquake load and wind load together. So, the combinations are also suggested in that particular code which I mentioned, IS 875 part 5. But there is one more important issue, is that partial factor of safety against load. So, we have tried to get the load from experience, consensus of experts and so on, but then still are we sure? Perhaps we are not. Since we are not very sure about the load and we do not want the building to collapse or fail, we add a factor of safety. That means, we multiply this load by some factor. That factor we call as partial factor of safety for load, and using that load as the design load we do all our calculation. So, I think that concludes our discussion on load type and how we take load into account. This is relevant from the point of view of materials and construction, because later on when we are selecting material, the load issues is going to come. Properties of the materials which you are looking for would depend upon the type of load it encounters. So, now we will go to functional requirements of building. I am talking of functional requirement of building. Therefore, I must look at the building process, building process. You see, how do we go about it actually? How do we plan and design the building, functional design of the building? I am talking of not structural design. Structural design is a second part. So, first part is the functional design of the building. Now, the person, the owner or the agency which is going to use that building or own that building, they decide what type of building he is going to construct. That is, they decide upon what is the occupancy type. I have mentioned occupancy type in the last class, like residential, industrial and so on. So, he decides what type of occupancy he wants to construct. That is his decision, what he requires, and then possibly engages an architect and possibly a team of architect and engineers and so on, and then based on the occupancy type, furniture and what is the circulation space you require, that is decided. I mentioned to you in the functions of building that circulation space is an important issue. So, therefore, circulation space and furnitures are decided based upon the occupancy type, followed by what are the spaces required. For example, in a school you would need classroom for so many classes, say class nursery for pre-primary section, nursery and KG. So, you might have 2 sections each, therefore, 4 classrooms are required in the pre-primary section. Then primary section class 1 to class possibly 5 or so, you will have as many number of section and number of classes. In an engineering institute like IIT, you will have so many departments and how many number of classrooms you require. Based upon the efficiency of use of the classroom, you can find out. So, the planners can find it out how many number of classrooms you require for a particular type of institution or particular type of occupancy. In a hospital, you will require an OPD, outdoor outpatients department. Then there are maybe department based on diseases, for example, department of ophthalmology and so on, and then you might have operation theaters and so on. So, you know what are the spaces you require depending upon the occupancy type and the requirement of the occupancy. Once you know that, then dimension of the space, for example, a classroom, what is the student capacity? If you know the student capacity, the code, in fact, there are corresponding IS code also, the codes or practices, various kind of practices which architects use based on ergonomics, movement of hand, writing, etc., one can find out how much space is required per person in a classroom. So, if you know so much area meter square per person per student in a classroom, the size of the classroom you can find out. So, the occupancy type, furniture and requirement of the space decides what would be the space, what is the dimension of the space, what is the area you require. Sometimes heights are important, like auditorium, you see the minimum height is supposed to be so and so for a given type of performance. A stage would require this kind of height, heights are again specified in code. So, depending upon the space itself, its circulation pattern and usage, you find out what is the dimension of the space, area, some cases height also. So, volume is also an important issue. Now, once these 2 facts are known, then you can identify each of the spaces. So, how many number of spaces that you identify, but important issue then also remains which space should be close to the next space, that means the relative proximity of the spaces. You first find out the spaces you require, what is their sizes, and then how close, which one should be close to which one. For example, if it is a classroom, it cannot tolerate noise. So, you should not have a workshop nearby, there should be a way, but some other cases you would like to have some classroom very nearby, because you want the students to spend less time in their walking, less time in traveling between 2 classrooms. This becomes very, very important in hospital, because it can be shown that in hospital planning, if you do a poor planning, you might waste a lot of money in terms of salary of the doctors and nurses if they have to travel a lot. So, proximity of the spaces, how close they should be or whether they should not be at all together is decided again based on furniture and circulation requirement. You want to minimize the circulation time, you do not want people to travel too much unnecessarily. And then site condition is important issue. If the site is of a given shape, then the building can only follow that shape, it can't be anything. You do not have an total open scenario unless you are constructing somewhere away from urban area. So, site condition is microclimatic issues which I mentioned earlier, and requirements of the site, local bylaws and things like that. All this decides together with the environmental requirements decides the shape and overall dimension of the building. So, as I said earlier that overall shape and dimension of a building is based upon its functional requirements. This is the process. This is the process which is shown here. Same thing I am just repeating. Furniture and circulation depends on occupancy type and functional use. Requirement of space depends upon furniture and circulation area. Interrelationship decides the relative proximity of spaces. Relationship between the spaces, they decide the proximity of spaces. Overall dimensions are decided depending on site conditions, environmental requirements and circulation. Also aesthetic. Let us look into some of those aspects of environmental issues like thermal comfort I mentioned earlier. So, let us look into some of those aspects of thermal comfort. I have said circulation and furniture, proximity of play spaces, etc. That is how we decide. But then envelopes are essentially can be decided, which may be non-structural, can be decided on this functional depending upon the functional requirements. For example, the wall thickness or the material you are likely to use in the wall or the roofing system, except the structural part. The structural part obviously you will have one, but on top of it, you might have some sort of insulation depending upon the climate you are in. Similarly, if you require noise insulation, the walls and the roof, ceiling, etc., they would act as noise insulation. The fenestration is a terminology used for opening areas that is kept deliberately designed opening spaces, windows and ventilators, which are by design they are left. These spaces are, these openings are left in the wall so that air can enter, light can enter. So, the fenestration design. These are, besides the structural system, these are designed based on functional requirement. So, wall or envelope as a whole, including the fenestration, shading devices and so on, they are decided based on the functional requirement. Other issues of planning from fire consideration, space for escape routes and so on, those are again from functional consideration. Sometime you might do compartmental, I mean, you can make compartments, fire compartments in the whole building, compartmentalization as it is called, from the requirement of spread of fire and so on. So, those are the functional requirements through which we design these aspects. Structural system is designed based on structural requirement, load carrying capacity and so on, but right now we are looking at the functional issues. So, let us see thermal and visual comfort and noise privacy, what we do in that case. Well, internal comfort condition depends upon air temperature inside, air temperature, relative humidity, air velocity within the room, circulation basically, and also radiant temperature. That means, if the surfaces are very hot, all the surfaces are hot, all the surfaces of the building are hot, then it would tend to radiate heat into the person. So, radiant temperature, as we said, it is related to the radiation from various surfaces. So, through proper choice of orientation of the building, design of the envelope and fenestration design, we take care of thermal comfort. Proper daylighting through fenestration, and if required by artificial illumination, we provide glare free visual environment, The amount of illumination required is a function of the space itself, function of the occupancy type, depends upon what activity is going on. For example, a corridor illumination required in a corridor will be much less compared to on a working table in a classroom or over a drafting table, drawing board or something of that kind. So, depending upon the visual comfort required, the desirable visual level required, contrast required and so on, we design it by providing proper glare free lighting. Now, what is glare free lighting? Glare comes when too much of light coming onto your eyes, light can get scattered into your eyes and your vision can get blurred. For example, if you are looking directly towards the car headlight, you get a glare, you do not see anything, you are totally blind for a few, momentarily blind. So, that is called disability glare. But there is something called discomfort glare, which you might have observed sometimes sitting in a classroom at certain angle you can't see the blackboard. That depends upon the contrast, the angle of viewing and so many other things. So, glare is a kind of discomfort, you can't see things properly. So, when I say glare free lighting, I mean that discomfort should not be there, you should be able to see without any discomfort and clearly you should be able to see. So, illumination level, contrast level, they should be such that it gives you a glare free lighting. So, by providing glare free lighting, one through the fenestration design by sunlight, sunlight allowing direct sunlight or daylighting as it is called, providing daylight, designing for good daylight, that is one thing. Secondly, if it is not adequate, because all part of the building, even in a deep room, you won't get good daylight, even if you have windows and fenestration design proper, you may have to supplement it by artificial lighting. So, by proper designing of this artificial lighting system, fenestration design, etc., you can get good visual environment. Then comes noise control. Noise controls and noise privacy. First of all, whenever you are doing environmental design, it starts right away from urban design stage itself, because if you can control of the site climate itself, then the design is relatively easier. If the site climate itself or the microclimatic modification is very high, then you have to take care of that. So, first thing is you try to see that microclimatic modification is relatively less, and that is what you can do even in noise control as well by zoning. Industrial areas are kept away from residential areas, maybe buffers are put inside, green areas and so on. So, by doing that, the noise in the residential areas can be kept low, so that you provide barriers, noise barriers, vertical walls, they serve as barriers, noise barriers, then insulation and little bit of planning within the building, etc., etc. By doing that, you can actually provide proper noise control and noise free or desirable condition within an environment which is not too noisy or not discomfort, it does not create discomfort. So, noise control and noise privacy through zoning, planning, barrier design, insulation and acoustics design in general. So, that is how we take care of thermal and visual noise privacy. Then fire protection is a is one of the most important issue when we are designing buildings for functional requirement. Building services, various kind of building services. Now, fire protection is one of the important issue, and fire protection again starts from urban design, zoning. So, you keep fire generating sources, for example, hazardous occupancies which stores explosive, far away from residential occupancies which are too sensitive to fire hazard. So, you keep them away, keep them separated, might put some sort of buffer, those which are not unlikely to be affected and so on. So, first thing is zoning, then by making proper fire protection measures. It starts from planning itself. Say outside the building, you first of all you leave sufficient space for firefighting vehicles, have sufficient fire separation. For example, a potential source of fire should be kept away from the building, like electric wire or something like that. So, fire separation should be adequate. There should be sufficient space around the building for firefighting vehicle to move. You might have fire hydrants, that is available water sources, piped water sources into the building. Then you have right kind of space, escape routes, well planned and well it should be, one should be readily see it, and or you might have an audiovisual system to warn people. So, adequate warning system, visual system, signages and so on, so that people can escape, and proper planning of escape roads. These are some of those aspects in the planning itself. Besides that, you can compartmentalize the building, so that fire does not go away from one compartment to the other. If it spreads, it does not spread too much. Then you can design the structural elements for adequate fire resistance. Unit of fire resistance is time, it is time. So, we will again discuss when we talk about materials, role of materials. So, you can design the members, the elements of the building or structure for adequate fire resistance. Now, these elements will be mostly structural elements, but non-structural elements, walls, etc., doors and so on. You can have fire doors. So, both structural and non-structural elements are taken into account while designing for fire resistance. So, proper firefighting provisions, maybe automatic firefighting provisions. Then you can have wet riser or dry standpipe, etc., etc. Various kind of building services are provided in order to take care of fire. You can have an intelligent system like automatic firefighting system. Well, I will just mention about intelligent building a little bit later on. So, this is what it is. Then providing proper condition, comfort condition or working condition within the structure or within the building through plumbing, electrical and communication services through their proper design and control. Lifts and other services. This becomes very important in very tall buildings, multi-story buildings, which are like high rise. There the design of lift becomes a very important issue, because one must should have an efficient travelling system, and the space consumed should be least, because the number of lifts you may require become too large if in case of a very tall building, something like 20, 30 or 40 story building. So, you have some lifts which will access express up to certain floor and then go passenger and so on. Otherwise, if it is stopping at every floor, then it consumes a lot of time and a lot of space also. So, lift design is a subject, and one can design the lift adequately and provide comfortable travel upstairs. Protection against moisture ingress. This is a very important issue, because this is an important issue in the sense that it is not only visual discomfort, but it has got a negative effect, that it may not immediately affect your any component of the structure except the visual part, that it looks moist, but in the long run it can create problem for structural members as well. For example, reinforcement corrosion, it is due to usually moisture ingress is one which triggers off reinforcement corrosion. So, other deterioration process in structural elements and non-structural elements can be due to moisture ingress. So, one has to take care of that, but taking care of that is by design some certain things can be done. For example, damp proof course into the floor level, in the plinth level which is provided, so that water from the ground does not seep inside, capillary rise does not take place. Adequate design against rain penetration where rainfall is very high, driving rain, against driving rain, which is a combination of rain and the wind. So, one can do that design for that, against that. Then leakage of pipes, etc. So, one can ensure adequate quality of construction, so that pipe leakages do not take place. So, these are the way how you can do moisture control. In addition to this, there are certain amount of detailing which are required. For example, dripping of water below a sunshade and things like that. So, detail detailings and good practice can give you comfort from moisture condition. And finally, in the functional requirements, one thing is very important, is that building requires maintenance. It is not maintenance free. This is what we tend to believe, that civil engineering structures as if they are maintenance free. You buy any other system, a car, a vehicle, or anything of that kind, or any other electronic systems also, they require maintenance. After a certain period of time, you have to do car, etc., mechanical system, you got to do overhauling. But it is thought as if civil engineering system, they do not require much maintenance. It is not so. They require maintenance, and proper maintenance enhances the trouble-free service life, because when your cost of maintenance is high, the cost is not only just the repair cost, but it is the disruption cost. Your activity, you might stop the function of the building itself. For example, if it is a classroom and that is not available for classes because a repair is going on, it means some sort of cost involvement. So, the cost is usually a cost of direct cost of repair plus the cost of disruption, and there could be if you delay it, there could be, it could trigger off further repair and further delay and so on. So, that therefore, at appropriate time maintenance of building should be done, whatever type of maintenance, both structural system and non-structural system. Maintenance of building system including service and revenue, this is very important issue, and one may look into what is called today life cycle costing. So, life cycle costing is the initial cost plus the maintenance cost and operation cost taken into account in an appropriate economic manner. So, this is about maintenance, which is also a part, I would say, part of functional requirements of building. Lastly, I would like to mention about intelligent building a little bit when I am looking at functional requirements of building. Now, you see, today, as I mentioned in the beginning, I mean last class I mentioned in the beginning, there is something called controlled environment and uncontrolled environment. A controlled environment is one where temperature is controlled. Now, there could be system where temperature fluctuates within certain range, whether it is in use or not. Similarly, all the lights are on, whether it is actually required, is in use or not. And so, when you have a control system and controlled through a controller, let us say, then a feedback is sent from that particular space to the controller, and which in turn controls the environment within the desirable range of temperature, humidity, etc. So, this has been used in air conditioning system for long. Similarly, automatic sprinkler system, you have sensors, in case of fire protection, you have sensors which will sense the heat or smoke or the dust or even sometime flame, and accordingly trigger of a sprinkler system. So, it is an intelligent system, it can do its things on its own. Intelligent buildings are those buildings where building senses or the space itself senses the condition and accordingly take action regarding maintaining it in a desirable condition. For example, it might sense the visual condition, the lux level, and accordingly put on the light or put off the light. There could be varieties of various versions of this. Some cases, the moment a person enters into the room, all lights becomes on. In a specific area, lights becomes on. So, intelligent building system, they have become common. They are also called smart building in earlier American terminology. These are ones who are fully controlled, computer controlled building systems, where the services are they are perfect, and envelope design also must be very efficient, otherwise you will be wasting. I mean, first your envelope design must be good, then the intelligent system works better. It is less it will be more economic and less expensive. So, that is what is all about functional requirements of building. I think that finishes the part of functional requirements of building. Now, we can look into the role of materials in general structural design or construction or in functional design of building. So, that would be our next topic of discussion. Well, one point I missed, that is need for bylaws. Now, when we are doing functional design of building, certain restrictions are required to be put by controlling agencies, because as I mentioned, the microclimatic modification is done by your construction, new urban constructions which you have provided, that would change microclimatic conditions. Similarly, one must leave certain space around the building for firefighting, vehicle to move around, or for placement of ladder and so on. So, such controls are provided through various bylaws. Local firefighting machinery that is available, that has to be that has to be taken into account while doing building design. So, local municipal authorities or such bodies, they put certain restriction on construction depending upon their ability and necessity, because one person, if he builds a structure or a building independently, he might disturb the airflow into the house of another person or possibly obstruct the light entering into the house of another person. So, therefore, some need for bylaws. These needs are now enumerated in the slides. Zoning and land use control, as I said, zoning is required for firefighting, noise control requirement. Then unobstructed air movement and sunlight, control of microclimate and site climate, firefighting provisions, protection against earthquake. In some cases this is required, because if you are in an extreme zone, you can't construct anything any way you like. For example, earthquake zone 5 by Indian Standard Code, yesterday I mentioned, the code I mentioned yesterday, the earthquake zone 5 is the severest zone. Now, there in such zone, one must construct according to the requirement of construction must be according to the requirement of earthquake safety. So, any tall building, if you construct a 50-story building there and soil condition is not good, then it might be susceptible to seismic calamities. So, that is why sometimes restrictions are put by the local authorities based on the seismic requirement, protection against earthquake. Then traffic movement and traffic privacy of the neighborhood. Now, let me define the neighborhood here. A neighborhood is a space, is a smallest unit in urban design, right. Now, such a space, of course, originally when actually conceived in United States of America around 1925, it was thought to be the populations, a population that can be sustained or that can sustain a single primary school. So, that was a kind of design. So, anyway, a neighborhood is one which requires traffic privacy. So, within the neighborhood no major artery will pass, no major traffic highways will pass, it will pass through the boundary. So, that was the concept of neighborhood. So, traffic privacy of the neighborhood, this is important. So, from that point of view, even bylaws are possibly required. You can't make any kind of roads. So, for example, through and through roads people will tend to pass through it, but if there are dead end roads or a cul-de-sac culminating into residential areas, cul-de-sac is a circular space into which a roundabout, a car vehicle can come and take a round and go back. Now, that becomes a fully private road from traffic privacy point of view. So, when I mention traffic privacy, I mean that actually that the traffic in a neighborhood would come and only for those people who are residing. No outside thoroughfare will not be allowed through such a neighborhood. So, bylaws are also required for that purpose. And then I think we can look into role of materials. Now, two aspects in role of materials. One, from the point of view of safety, that is the first fundamental. When we are trying to look into role of materials, two aspects are most important. One is the safety and second is the functional requirement. The most important one is the safety aspects. So, let us look at aspect of safety. What is the role of material when you are looking at safety of the structure, and then we will look into role of material in functional design. As I mentioned earlier, structural system design, it is the one which resists the load. What is the structural system? For example, in a framed building, the load, structural load simply may be carried by the columns and the beams and the slab, and the walls may not be load bearing. In some cases they will be load bearing, but not necessarily they will be load bearing. In buildings above 4 or 5 story building, in Indian condition, the type of brick normally you get, the buildings are usually non load bearing. Even up to 4 story buildings are many cases are walls are non load bearing, they do not bear the load. Structural load is borne by the column, beam and slab system, that is called a frame system. There are other kind of structures, maybe something like a dome, something like plate shells, there are varieties of structures. In a bridge, of course, the non load bearing structures are very little, or such structures, infrastructure projects, their non load bearing structures are relatively less. But in a building you can have non load bearing envelope like walls, right. So, loads are resisted by only the structural systems which are load bearing, and structural system consists of members like I said, beam, column and slabs. They are also called elements, and they are connected by some means, they are connected in some manner, maybe single joined, what is called monolithically, that means they are supposed to act as single unit, or you might have some sort of connections between these elements or members. Now, when I do structural design, what I do? I actually consider the elements and the members together, and then idealize them as some sort of system, so that I can apply mathematical treatment. For example, a column may be thought of, a column is a vertical member, which has got less dimension in x and y direction compared to z, that is the vertical direction. So, that is a column and usually resists the load, resist downward load, that is gravity load, usually resists gravity load, but whenever any horizontal load is there, even that component of some effects comes onto it as well, but usually it is a vertical member. A column is a vertical member and its dimension, planar dimension in plan is small compared to its vertical height. So, that is a column. Now, a column is a structural element or a member, Now, this column loads usually acts downward onto such kind of columns. A beam on the other hand usually is a horizontal member, and its dimension in the transverse direction, that is the direction along the span. There is one long direction, that is called the span, and the dimension along other two directions are very small, relatively small. A slab is a two-dimensional member. It has got dimensions both in x as well as in y direction, and in z direction its thickness is relatively less compared to x and y dimension. Now, when I am idealizing a structural element, for example, a column, I assume as if it is a as if its load will be acting downwards and its connections are also idealized, so that I can treat it mathematically. Actual connections, what they are, how they transfer the load from, let us say, beam to the column, that may be slightly different than what we actually design. In design we conceive or idealize as, but we got to idealize it because we must make it to amenable to mathematical calculations. So, that is what we do. So, what we do, we try to first idealize the structure, and once the structure is idealized, then we try to find out how much the force an element will have to bear under design load condition. So, I know the design load condition, and then mathematically I find out from basic principles of mechanics, which you must be studying somewhere else in a mechanics course. So, using basic principles of mechanics, we find out how much is the load the column will have to bear or the beam will have to bear. So, that is what we do through structural analysis. We call it structural analysis, through which we find out the forces, and these are computed. Then size of the member for the material used must be able to resist the design load. So, design force that has come onto it. From the design load which I have taken, the load may not come directly onto the column. In a beam column slab system, a frame system, the load will first come onto the slab, then from that slab it will be transferred to the beam and then to the column. So, the amount of load that is coming to the column, that we try to compute through structural analysis, and then find out the size of the column which is sufficient to withstand that load for the kind of material I am using in the column. So, therefore, material is an important issue. What material I am using, that will dictate what size of it, what would be the size of the column, or what would be the size of the member, right? What would be the size of the member. Two types of forces. There are mainly two types of forces or stresses, I would say, in case of such structural members. A pull, that we call as tension, or a push, which is compression. Well, you have shear, which is sliding, Now, many times shears, complementary shear can be resolved into a pull and a push, combination of pull and push. However, shear is other kind of stress that the element has to, the member has to withstand. So, these three types of stresses, pull is tension, push or compression, and sliding or shear. These are three types of forces mainly it can encounters. Some other cases shear would come, shear may come from bending or come from various sources, but these are the kind of forces one encounters. Then the member must be able to resist this kind of forces. So, it should have those strengths sufficient. We will look into that. Now, a member is said to be loaded axially when load is parallel to its long axis. When load is parallel to its long axis, a member is said to be loaded axially, like a column. Column, as I said, the load usually to withstand downward load. Therefore, it is usually axially loaded. There may be some eccentricity, but axial load will definitely be there. If there is horizontal load at the top of the column, it is not axial, but then it can cause some sort of bending. But axial load is always there in a column because the self weight would definitely be there. On the other hand, a beam, its self weight acts in the downward direction, whereas its length span is in a horizontal direction. So, the load is acting transverse to the direction, transverse to its axis, long axis. Load is acting transverse to its long axis. So, that is transverse loading. So, when load is perpendicular to the long axis, and that usually results in bending, that usually results in bending, you see. So, axially loaded members and then bending, there can be combinations, of the both. Now, therefore, material should have adequate axial resistance against axial loading, against bending. Now, this bending is also called flexural resistance, flexure, it is called flexural resistance, and must have good shear strength. Since it is likely to face axial stress, that is either tension or compression. In case of column, it is mostly axial compression, and then flexural strength, that means resistance against bending, and sometimes shear strength. So, this flexural strength can both be compression and tension. Some cases in multi-story building, the structural elements, their strength to weight ratio is very, very important. Strength to weight ratio is important in some structures, in tall buildings, because more the weight of the structure itself, it is likely to cause more load will be actually imposed on the lower stories. So, you like to have things lightweight as much as possible, but it is more important in aircraft and such structures, strength to weight ratio. Civil engineering structures, well, some cases, not always. But some cases in civil engineering structure you might require robustness, that is massivity sometime. Robustness I refer here is massivity. For example, a dam. In a dam, the water is on one side, which might push it due to hydrostatic pressure. Now, it must have adequate resistance against sliding. It should not slide against water pressure. It should not slide, as a dam as a whole should not slide. So, it should be stable against sliding, and therefore, it should be robust. That can come from its massivity. Similarly, many walls under horizontal loading, it should not topple. There is overturning, it should not overturn. So, this is stability against overturning, against sliding, and this stability against sliding and overturning, that comes when you have heavy mass. You can't slide a mass, nor you can overturn it easily. So, that is robustness. In civil engineering structures, sometime you might require robustness, that is the massivity. So, you need weight, a lot of weight, and therefore, your material, if it is heavy, that is fine. But in many other cases, you would like to minimize the use of material, because that is cost you money. Less material, cheap material, that would be the cheapest situation. So, robustness is also required in civil engineering in some cases. Well, you need adequate stiffness, For example, it should not bend too much, it should be stiff. If it is, if a building frame, a beam is bending too much and you can feel it, then you will feel uncomfortable. It may not fail, but it should not deflect too much. Deflection, you might feel uncomfortable. So, it should have adequate stiffness, and this stiffness comes from a property called elasticity, modulus of elasticity. You would have come across this terminologies in physics and mechanics, strength of materials and so on. So, modulus of elasticity is an important property which will give you stiffness. So, as we are looking at the role of the material, first of all, the most important role of the material is to provide adequate strength, axial, under against flexure, axial and under axial loading, that is axial compression or axial tension. Then flexural tension or flexural compression, should have good flexural tensile strength, good flexural compression strength if it is required, should have good axial tensile strength, should have good axial compression strength, should have good shear strength, and then sometime you might need strength to weight ratio, sometime you will need robustness, and then stiffness is very, very important. So, therefore, modulus of elasticity should have good modulus of elasticity or high modulus of elasticity as required. So, whatever is required, high or low, that has to be decided by design, by thought, by pre-thought only, and the material has to provide that. So, you select a material based on whatever is your requirement. This is the first mechanical properties. Let us see something more towards the mechanical properties. This is an important issue, post-elastic ductility. Post-elastic ductility is an important issue. What is ductility? It is the capability of deformation before failure. A formal definition would be given a little bit later on, but why do we need this? Adequate warning through large deformation prior to failure is required. I must know that failure is, I must get warning for impending failure, so that I can do evacuation or whatever it is. Now, I can give you an example in case of earthquake design. You see, since we are very uncertain about the extent or the intensity of the earthquake which I am likely to encounter, it's very difficult to predict. It's very, very difficult to predict. in the life of the structure, what is the intensity, maximum intensity of earthquake it is likely to face. That is very difficult to predict. So, the strategy for earthquake design is like this. If it is an small earthquake, normal, not very not very unexceptional or something like that, not very not very exceptional earthquake. So, what will happen in such situation? Nothing should happen to the structure. It should stand erect, every component of it, including all the non-structural members. But if you have a moderate earthquake, the earthquakes and their intensities are classified into low, moderate and high. So, moderate earthquake, well, structural elements should remain intact without any damage, but some of the non-structural elements may fail. Non-structural elements failing does not cause really any danger, because it can local danger is there and people can take protection. So, non-structural elements can fail. But in case of a high intensity exceptional earthquake, which you have never envisaged, the structural elements can get damaged. Maybe it would break some places, but complete collapse should not take place. So, how can you? It can break, but still should not collapse. That means it should allow for large deformation. In a beam column junctions, there should be sufficient rotation capacity. It can it can tilt or do something, but finally it should not collapse. So, that is what necessitates, that is what requires for such kind of action, that it should deform a lot, it should tilt, but should not fail. Should not fail without going into showing lot of deformation or lot of tilt, lot of rotation and so on, lot of cracks development. That property will come if I have good ductility of the material. So, sometime it is required that material should have adequate ductility, that is, should have sufficient deformation before failure. Another important aspect is endurance limits against fatigue. I mentioned fatigue. Fatigue is nothing but reversal of stresses or repetitive loading, like a vehicle comes over the bridge and then it goes away. So, that actually imposes repetitive load, right. There is a stress is applied and then withdrawn, stress is applied and withdrawn and applied and withdrawn, and that cycle continues. So, the load which it can withstand after at infinite cycle, because a static loading where it fails, if I go on increasing the load, at some load it will fail. That is only one cycle, that static monotonic loading, the failure static strength actually. A fatigue strength is much lower than that, which I can reverse, do the reversal of that particular load, apply or release the load, apply and release the load for infinite number of cycles. So, that is the endurance limit, that is defined as endurance limit. Well, infinite number of cycles we actually restrict to 10 to the power 6 cycles, a million cycle. The load reversal which the structure can withstand for 1 million cycle, we call that as endurance limit. So, where fatigue loading is important, I told you about bridge or maybe offshore structures where the tide will come, hit it and then again it will go back. So, there is a reversal of stresses. Such places where there are reversal of stresses, fatigue is an important issue and the endurance limit is a property. So, I might require endurance limit from the material where fatigue is my concern. Not all places everything will be in my concern. Some places I might require, I demand from the material that it should have good endurance limit. So, I select the material accordingly, right. Okay. And then impact toughness. Some cases I would like to have good impact resistance. Say where supposing I have a forge hammer foundation of a forge hammer, forge hammer is used for smithy. Okay. So, quite industrial situation, one may produce some material, mechanical industries through a forge hammer, and such a forge hammer actually impart large amount of impact onto the foundation. So, foundation should be material which I am putting into the foundation should be able to withstand that impact. There may be many other situations where impacts are important. Blast could be important in blast resistant structure. So, therefore, I should have my material which should be able to withstand this blast. The property that is important in such situation is called impact toughness, that is the energy it can withstand before actually failure at under impact, failure under impact. So, that is called impact toughness. So, this is important. Then industrial flooring, abrasion resistance might be important, because I might be rubbing a lot of or pulling certain materials. So, there is abrasion. Even bridge wearing coat, where vehicle moves, the wearing coat top, that should have good abrasion resistance. So, pavement should have good abrasion resistance. So, material should not go away under abrasion. Railway sleepers, they requires resilience. Resilience a property is the amount of energy it can withstand up to elastic limit. Where stress, elastic limit is that point up to which if you apply the stress and release the stress, it will come back to its original position. That already, must be from some strength of material course. So, the energy up to elastic limit, half stress into strain up to elastic limit, is called resilience. Some cases you might require good resilience of the material. It should be able to stand good resilience. So, railway sleeper is one such example. It should actually withstand a lot of energy when when the vehicle, the train wheel has come or train has come, and when it goes away, it should come back to its original position. Should have a good resilience property. Some vibration control system or isolators should have good damping properties. That means, it can dissipate a lot of energy under vibration. So, some cases you might demand a bridge bearing, for example, neoprene bearings which are used commonly in bridges, they are the ones where possibly you require good damping properties of the material. And the next one is functional. So, these are so far what I talked about was related to safety. The next one would be related to functional requirement. What you demand, what is the role of material in functional design of building, or in functional requirements of building. So, that is what we are trying to look into now. Now, when I am looking to role of the material in functional aspects, the functional design of in functional requirements of building, we have seen that there are thermal requirements. Now, if thermal requirements, the material should have right kind of insulation properties, that is, it should have low thermal conductivity or proper thermal conductivity. I did not say low, but it should have required thermal property, thermal conductivity. Then thermal diffusivity, which is a derived property from specific density and thermal conductivity. Essentially, it means the ratio of conduction to the storage in the material. So, that is thermal diffusivity. It should have good or proper thermal diffusivity. That means, specific it should be also appropriate. Then thermal expansion, coefficient of thermal expansion, that is not really from environmental point of view, but thermal expansion is related to temperature loading. So, therefore, it should have proper thermal coefficient of thermal expansion. These are the properties which are important from thermal point of view for materials. But then surfaces, for the surfaces, the important ones are, for example, external surface. Whitewash surfaces are supposed to be good, because they have high long wave emissivity and low short wave absorptivity. So, they are accepting the radiation or refusing the radiation, that property is important for the surface materials. Sun's radiation is short wave radiation. So, we do not want the heat radiation from the sun to come into the building or not into the structure. So, if it should have low short wave radiation absorptivity, should absorb less short wave radiation. But then when it is heated up, eventually, although it receives some amount, it will radiate this heat to the environment, to the outside sky in the night, when cool sky in the night, and it must radiate as much as possible. So, it should have high long wave emissivity. So, this emissivity and absorptivity property of surfaces are important. So, that is what has been mentioned here, long wave emissivity and short wave emissivity and long wave short wave absorptivity and long wave emissivity, these are also important aspects. Then in case of sound, transmission loss quality of wall, that dictates its insulation. And if you are trying to control against structure borne noise, then transmissibility of the wall against structure borne noise is also important. You put mounting. So, these properties of mounting damping properties of mounting. A mounting is a small element put between a vibrating machine and the floor. So, properties, damping properties or transmissibility of this mounting, they are important. So, sometimes you might demand from the material to give you right kind of property. For example, a cork board, this should have good damping properties. Absorption coefficients of materials, they are required in acoustic design of auditorium. So, this is again property of the element, constructional element altogether, including its surface, not of a material, but the whole construction as a whole. Fire resistance of elements. Fire resistance of elements are expressed in time. It is the time up to which it can withstand the fire without losing its integrity, insulation quality, and should remain stable, should not collapse. So, fire resistance is in terms of time. So, materials, you might demand a good fire resistance of the material. Well, I am not going to discuss detail what is fire resistance and things like that, but you might demand the material may be required, or the construction, not material as a whole, but the construction may be demanded to provide adequate fire resistance. Hydraulic diffusivity, permeability and vapor transmission coefficient or transfer coefficients, these are required against moisture ingress or moisture migration. These are required against moisture ingress or moisture migration. Hydraulic diffusivity. So, you might demand from the material these properties if you do not for a proper blocking of moisture. Reflectivity of surfaces are important from lighting point of view. All right, I think we have nearly finished our discussion of role of material, except for one slide which is related to some specific material. Durability, of course, is one of the most important issue related to all material. It might have good strength, but if it is chemically attacked by external agencies, then its durability is not good. It should be durable, it should last long without getting degraded. So, this is a property which you demand from all material all the time. For example, some surfaces might deteriorate under ultraviolet radiation when exposed to ultraviolet radiation. Concrete may deteriorate when in presence of sulphate. So, we have to look into these issues, and we might demand good durability from the material, right. And a special case, some material which are moldable material, like concrete, it is a moldable material, and plastics are also moldable material, but from civil engineering point of view, concrete is an important aspect. So, their properties of the fresh state we would like to also look into, their properties in the fresh state is an important issue. So, materials plays a role in its fresh state, and then when it is formed during its service life, it should have adequate strength and other functional properties what we demand material as well. To summarize what we have seen so far in this module of 2 lectures, what we have seen is looked into types of loads that encounters. One of the functions, main function is of course providing safe environment, and from safety point of view they have looked into what are the types of loads it can encounter. Then we have seen what are the functional requirements of the building. The second aspect, the functional, first is the load type, then is the functional requirements, right. First is the load safety requirement, then is the load functional requirements. So, we looked into the functional requirements, and then we try to look into the role of materials. In the next module, or we will look into the materials themselves. We will start with some of the materials, notably concrete and so on. Thank you very much.